Buenos días a todos. Como dijo Jesús, me llamo Joe y yo he trabajado en Mayer por ahora 13 años y yo trabajé juntos con EPSA ahora como ya tiene 7 o 8 años trabajando con ellos. Y otra vez gracias a Jesús y a EPSA para empezando esta clase y gracias a todos que están aquí para su tiempo. So just to briefly start, pienso que todos nosotros ya sabemos que es una válvula rotativa, but just kind of want to go over it real quick. So the basic rotary valve functions, if you want to maintain the airlock, maintain the seal, you have material dropping in through the top and then dropping in through the bottom. Different equipment will be above it and below it. Different materials go through it. Really what it comes down to is what is the expectation for the rotary valve? What do we want it to do? What does the customer want it to do? What does the end user want it to do? A lot of that will then come down to the application information. I'm sure most of you have seen the sheet that either we pass out or that EPSA will pass out or fill out with you and ask all the questions on what is the valve doing, what is the material it's handling, what's the pressure, what's the temperature, what's the equipment. All of that ties into how the valve is going to be used and how it's going to be built. And how it is built is probably the most important aspect of avoiding problems. At the very most basic level, is the rotary valve acting as a feeding valve or is it acting as a sealing valve? Is it going to just control the rate of material or is it going to... Sorry, hold on, the slides weren't moving. As I mentioned, I got the material dropping in, material dropping out, the application information, how is it going to be used, what is the customer going to do with it, what do they expect it to do. If it's a feeding device, it's going to be controlling the rate of material. If it is an airlock, it's going to be sealing against air leaking past it. There are also times where it'll be both an airlock and a feeder. We're going to maintain that pressure seal and control the rate of material. Depending on what industry you're working in or working with or where the customer is at, there's any number of materials that will go through the valve, either food grade, chemical grade, abrasive, non-abrasive, asphalt, wood dust, again, any number of materials will go through it. The most common rotary valves that we supply and we sell is the HDX valve that is going to have the broadest range of applications, can handle pretty much any material, and will also have the widest range of options that it can use. The side entry model is used for larger particle sizes, which again, the information we want to capture on the front end as far as the application products being used, as long as we supply the correct valve that can help avoid a lot of problems. And then lastly, we do also offer the KIP2 stainless easy clean valves. Just real quick, just the brief overview of all the components of the rotary valve. Got your rotor on the inside, housing, head plate, bearings and seals, and then the drive obviously on it as well. Now, again, the main concern with the rotary valve, the main issue you're going to run into whenever you have a problem or when you know you need to replace it is when it's leaking. There's two different types of leakage. All rotary valves leak. If anyone tells you they have a leak-proof or a leak-free rotary valve, they are not telling the truth. There's two ways that rotary valves leak. The first of which is the displacement air leakage, and the second is the leakage across the clearances. For the displacement air leakage, what that is as the material on the top of the hopper or silo, whatever's above the valves, as it enters the valve and flows through, it then drops out of the bottom of the valve, and then the ambient air that's below the valves enters into the rotor pockets. This is especially true in a pressure convey application, where you're going to have that pressurized air fill up those rotor pockets, and then as that rotor continues to spin, that displacement air is going to leak up and through the valve. The second type of leakage that will, again, always occur on all rotary valves is the leakage past the clearances. So even if the valve is not spinning, you still have that small gap between the rotor and the head plate and the housing, and you will have some leakage air go past those clearances. There's no rotary valve out there that has a zero gap. unless you're talking about a flexible seal strip rotor. The other type of leakage that you'll see that people know when they have a problem is leakage through the rotary shaft seal. Normally you'll either see little puffs of air escaping out that, or I've even seen instances where there's a pile of material next to the rotary valvenet seal area. Now, the ways that we eliminate that leakage or avoid it or try to limit it as much as possible, the first of which to limit that displacement leakage is to run the valve as slow as you can. So you want to meet your rate, you want all the material going through the valve, but if your rate is low enough and you can achieve the rate with, call it maybe a 10 RPM speed, you don't want to run the valve at 20 or 25 because you're just adding displacement leakage. As far as the leakage past the seal, the way we target that is all based on the temperature of the material that the rotary valve is going to handle. When you have a higher temperature material, we need to increase that gap, increase that cold clearance for when the valve is built. Because what will happen is that hot material hit the rotor will heat up and expand and then close up that gap. So if we have improper application information and we set up the valve for say 200 degrees C, but it's only ever going to see 40 degrees C material, that gap is going to
I think you can don't share the presentation. Yeah, we can see now.
So having the proper temperature called out is key. Again, just so that we can truly have the correct clearances set up. Because you want to maintain that airlock, you want to maintain that tight gap between the rotor and housing. Having the correct temperature is ideal for that. As far as leakage through the seal area, the main way to prevent that is to do proper maintenance on the seal, tighten the packing gland nut, periodically replace the packing seals here and there, or the other option is using air purge shaft seals. That will replace one of the seals here, one of the packing rings, with a lantern ring. You can then introduce positive pressure air and create an air barrier that then prevents material from escaping past the rotor shaft area through the seals and out through the valves. The key with any air purge application is proper sequencing. The air purge must be turned on before the convey line is turned on. It's one of the most common issues we see when people have leakage issues, even when they have the air purge. They, hey, I've got the air purge, I'm still having leaking, I'm still got material coming out through the shaft area, what's going on? And more often than not, what we find is that they did not sequence it properly. Because what will happen is if you turn on the convey air before the air purge, you can get material trapped in that lantern ring. It will become plugged and will not function as it needs to. And then in order to fix that, you have to tear the valve down, replace the lantern ring, or fully tear it apart and clean it out. Most people don't have the time available for that additional downtime, and then it ends up costing them money. With that, the next probably most common complaint that we receive with rotary valves and that we see again often in the field is the valve is squealing or making noise.
Sorry, just we can see the first slide. I think don't no, this is the second slide. Okay.
The first slide.
You change the slide?
They said you wanted to see the first slide?
We see the rotary valve function.
the slide that you wanted up?
Sorry. It's we can see the second slide. Yes.
Was it the slide that you wanted up?
Do you share the slide? They have
Yeah,
a
you
rotary.
already see the second slide. It's okay.
Is everyone showing the basic component slide now?
I see the HDX rotary bulb slide. You changed to the rotary bulb basic components slide?
Yeah.
Yeah.
So then for the noise, whenever a valve is experiencing squealing, generally the first question, is it cyclical? Does it come and go? Is it only on startup? Normally what we find the two most common causes for any kind of squealing is, the first of which is temperature. If the clearances were set for a lower temperature and now a high temperature material is going through it, that rotor will heat up, expand, and can start hitting the housing, can start scraping against it. We'll get a metal on metal squeal. The other main cause that we'll see is material buildup. So depending on what material is going through the valve, for example, if it's a hydrated lime or sugar, tends to smear across the inside of the valve, can cause buildup. And then when that rotor is then kind of scraping against that material, you'll get a rubbing noise or a squeaking and squealing noise. The other possible cause we see sometimes is if the rotary valve is being ran backwards. The beveled edges will actually collect material and can cause the valves to squeal or possibly even lock up. The other thing that then leads into kind of the next issue is the rotary valve jamming or binding or locking up. Again, the most common cause of that we see is temperature, either an elevated temperature spike if there's an upset condition in the system, where either something happened above stream where now you're getting 300-400 degree material coming through a valve that was only set up for 40 or 50 degrees. That rotor's going to heat up, expand into the housing, and lock up and stop spinning. So again, the way to avoid that is to have the proper application information up front, have the valve designed for the correct temperature. The other way to avoid it, if it's material buildup, if material is either binding or jamming, you can get that hygroscopic material building up on the inside. Or if you have larger particle size, for example, a sawdust application where you're actually getting chips and chunks, or a pellet application, if that rotor is pinching on that material and binding and jamming, the way to address it is either with a mountable tip cleaner that deflects the material on the top, or there's different rotor options that we can build the valve with. We can either do cutter edges, which kind of helps scrape that material off of the buildup. We do knife edges, which is what we often do when valves are handling sugar, where they land on the rotor bevel. If you got your bevel on the edge here, will reduce the size of that land, where now you have less friction between the rotor and material, less heat transfer, and less.
You close the microphone. We can't hear you. Hey, you?
Can you guys hear me now?
No, yes.
Sorry, my headset battery just died on me in the middle of the presentation. So with the jamming and binding, if it's material buildup, there's different rotor options we can build the valve with to address that. You can do flexible seal strips, full face flexible seal strips if we know it's a larger particle size. Do the cutter edges, the knife edges, where it can scrape away that material as it builds up, or the knife edge can help eliminate that buildup before it occurs. The other thing that can happen, and we've seen it before, is if the valve is locked up and not spinning at all and there's no material present. We've seen sometimes where maintenance staff will over tighten that packing gland. So again, if you've got that packing gland right here, I don't know if the mouse is showing up for you guys, but if you over tighten that packing gland, you can compress the packing so tight that it actually clamps onto the rotor shaft and prevents the rotor from spinning. So oftentimes we'll again ask customers to check rotation, make sure it's not spinning backwards, make sure it's not getting excessive material buildup, verify operating temperature, verify that there's no screwdrivers or anything dropped into it, because we've seen that as well. Where you got someone working in the hopper above the valve or working on the system above the valve, and they either drop a piece of wood or drop a tool, and then the tool falls down and jams up the valve. The other potential cause will be a bearing failure, which can happen due to material contamination. Again, if it's a pressure convey line, you have material leaking out, those shaft seals, it'll leak out and get to that bearing. So again, having the proper features, having the valve set up for the application it's going to be used in is generally the best way to eliminate that from happening. Otherwise, if it does lock up due to bearing failure, you have to tear the valve apart, replace the bearings, and then reassemble it. See, as far as extending the life of the rotary valve, kind of what I was alluding to in the beginning of the presentation with that displacement leakage, the absolute best way to improve the life of a rotary valve is to run it slower. The wear generally occurs from the abrasion as the rotor spins. The material gets pinched between the rotor, the housing, and the head plates. The more abrasive material, the more it grinds away. So if you can run the valve slower but still meet your rate, that is the easiest way to add life to the valve. It doesn't require any additional money, any additional options, any additional features. Just run it as slow as you can while still meeting your rate, and you're going to add additional life to the valve. The other way is to make sure that the valve is properly sized for the application if you're trying to eliminate leakage and you want your system to run more efficiently for a longer time. If you have too large of a valve and you're running it too fast, you're just going to get excessive leakage. You're going to get more leakage past the clearances in a larger valve. You're going to get more displacement leakage moving past it in the larger valve. So again, having it sized properly is another way just to have it running more efficiently, where again, if we capture on the front end and we size it properly, equip it properly, you're going to get much more life out of it. The two most common features that we see added and recommend to add life to the valve is the air purge shaft seals. Pretty much anytime we know there's a pressure convey line underneath the valve, we recommend using those air purge shaft seals. You're going to protect the shaft seal area. You're going to eliminate the material leakage through the shaft seals, and you're going to improve the product quality as it's going through the valve. The other option that we push as much as we can for people, some of us, we call it cheap insurance. Anecdotally, you can triple the life of your valve. That option will be hard chrome on the valve interior. So we put on the housing bore and on the head plate interior. Again, it just gives it a much more abrasion resistant surface. If you have material buildup concerns, the chrome can actually also help with material release as well. The cost of the chrome relative to the cost of the valve is anywhere between 5 and 10%. So for the additional life that it adds compared to the cost, it is probably the #1 option that we recommend adding onto the valve. Depending, again, on the material that's going through the valve and what the application is, there's all different kinds of seal strip options that we can recommend. Those seal strips are bolt-on and replaceable. We have flexible options. We have rigid options. We have abrasion resistant. We can do stainless bolt-on if corrosion is the concern, not necessarily abrasion. As we move into the more abrasive materials, you can have customers who are replacing their valves maybe every 2 or 3 months because it's worn out and leaking too much to where they're losing throughput, their blower's running higher, their energy consumption is higher. Then, kind of first step we'll say, hey, do chrome, do AR steel seal strips. Those will last longer. For some customers, they still want it to last even longer than that. We can offer harder coatings. We can do tungsten. We've done ceramic tile in the past. We don't do it that often. We found better luck with tungsten as far as maintaining a better seal and a better price point. We can also offer hard facing on the rotor tips and ends. It's a stellite-like material. It's got a Brinell rating of 650. So you can weld that along the tips and ends on the rotor. So you get additional sealing, additional abrasion resistance across all the points. We can also do shallow pocket rotors, reduced capacity rotors, split and staggered rotors. Again, it all really ties back into what the expectations are from the end user, from the customer, what the valve is being asked to do, what they want it to do. All of that then ties in with what we recommend. And then obviously, if you're ever having any issues, if we can identify what's going on with that, we can then recommend whatever features or options we think would be best in that situation to avoid those in the future. And again, as far as determining what's causing that, video is very helpful. Photos of the valve once it's pulled from service, or even video of it running, can help. I know the gentlemen at EPSA are fantastic and would always be willing to do a site visit if you need someone to come on hand and look at a system that's installed, or look at valves that are installed. We do offer repair and inspection services at our facility in the States. Depending on the size of the valve, it may be cost prohibitive to try to ship it back to us for the inspection, but certainly if it's a large valve, 16 inches, 18 inches, 22 inches, and there's concerns about life, and someone wants a true full teardown and inspection, we do offer those inspections and evaluations at no charge. The only caveat being is that it would have to get shipped back to our facility to do that. So again, then a lot of that really comes down to where the wear is occurring. Depending on where it is on the rotor, we can recommend different up-armored options. We can offer chrome in different places on the valve body. We can offer tungsten on different places on the rotor, replaceable tips, bolt-on tips. We have kind of the good, better, best level of abrasion-resistant options. We also offer different pieces of equipment as airlocks, double flap gates, screw pumps that themselves are more abrasion-resistant and maintain a better seal for longer. They do cost more, so a lot of times it's kind of what's your pain point, what's your price point. The screw pump is an absolute fantastic piece of equipment. It runs incredibly well, lasts nearly forever. You can replace parts on it if you need be, but you're typically starting at about $50,000. So usually for a lot of those, it's how many problems are you having, and are you ready to commit to that next level solution? Whereas for the majority of customers, just up-armoring the valve or adding some different features or options as far as venting or air purge will generally get the problem solved for what they're having.